Hello, welcome all. And this is the part 3 of our Helm series. And in this part, we are going to learn about our first Helm chart in Kubernetes. So we are going to see how we are going to create our first Helm chart. And this is going to help you to get started with the charts inside the Helm. Now, that being said, let's get started with it. Okay, so we are going to create a Helm chart in this video, and we are going to create it from scratch. Now, to create a Helm chart, you can start by giving the command helm create my chart. This command is going to create a my chart directory, and that my chart directory is going to contain your chart templates, which you can use to create your chart. Okay. Now, you can modify this chart, the templates and the files which this command has created inside the mychart directory as per your own requirements. Now, if we talk about the Helm templates, because this command is creating what we call as chart templates, right? So these Helm templates are basically written in Go template language. Go is your programming language. So it has been written in Go template language, which allows you to generate the Kubernetes manifest and files at the time of the deployment. To create the Kubernetes resources, you need to create a file, basically a directory under your mychart directory, which has been created. You need to create a templates directory under it, and then you are going to create the files with .yaml extension under it. Like, suppose if we have to create a deployment. So here we have shown a deployment template. If you see here, it shows a deployment template, and which starts with apps v1 API version, which is for the deployment kind is deployment metadata. Now here you will see that we are using a variable like Release.Name. This basically comes down to the release, the name that you are going to specify for your package during the installation. That same .release_name will be replaced by it and appended by deployment. Now this helps you to follow the same YAML file. You can actually deploy multiple application using the same syntax, right? As soon as you change this release name in your command with the Helm installation, the same name will be applied to it, right? So basically you can think of this like a dynamic YAML template that you are writing. This is going to improve your redundancy inside your repository. That is, you don't have to rewrite the same template again and again and then deploy, right? So that kind of thing gets automated, which is very pretty much useful, because you are going to manage large number of application, and this is going to reduce the amount of time that you have to put towards writing these YAML templates, right? So you can specify this release name deployment, then you can put on the labels. Now, if you see that how I have structured is like by including this release name, now which is very specific to my application name, right? So this is going to append it, and we are writing less of the configuration, still following best practices, right? So that is how we can include the labels as well. Then we are specifying the replicas. Now within the replicas, you are seeing that these values can change for different applications, right? So some application might want to run 3 pods, other want to run 5, other want to run 10, 20, depending upon the traffic that you are going to receive, right? So this creates a variable. Now what we can do is we can store these inside a variable as .values and .replica count. Now this replica count is a variable name which we are going to store inside the values.yaml file, which we can write separately for our application, and it will pick up those values.yaml file and accordingly replace its values at the runtime. So this is how Helm can create the dynamic configurations for you. Right. Next, we are going to specify the selectors, which actually matches all the pods which are already running and makes it a part of our deployment. Right. So we are going to match its labels. And if we find any pod which is having a label already matching to our app name, that will automatically become a part of our deployment. Again, I have replaced the labels with my application name to make it more dynamic. And similarly, we are going to put the templates and make sure that all the pods created by the deployments are having those labels, right? Next, we are going to specify the specification of our containers. Again, the name of our container, I have created a unique name using the application name itself. Then within the image, because image repository will change, that is each time you are creating the pods, you are running the container inside those pods, you need to call their image, right? Now, those image will be different for different applications. So if we want it dynamic, then we can call those values of image repository and image tag, right? And put it inside the values.yaml file, which is helping us to stay. This helps us to prevent any hard coding of these values, so that we make it more dynamic in nature again, right? So we have again put this inside the, we can put them as a values file, values okay, inside our values file. So I will show you this shortly. The image repository and image tag, you will find it inside our values.yaml file. Again, now since the ports also will differ for each application, so the container port is also mentioned inside the values file. That's why I have declared it here as a .values .container port, like that. Okay. All right. Now, so here you are seeing that I have created a template with a .yaml extension, and I have actually written my deployment mostly in the form of a dynamic deployment file, which is going to be replaced at the runtime with the values that I'm going to provide. And some of the values it's going to confer from the values.yaml file. So let's take a look at the values.yaml and how we can make a use of it. Now, if you see this values.yaml file, it basically holds the values for your Helm deployments that you are going to do. So you can specify the default values here. Now, when I say default values, it simply means that if someone is running just Helm install package name and not providing any value, then it can pick up the default values, which I have set up inside the values.yaml file, and it can go ahead and do the deployment. So that is kind of a default value, what I mean to say by default values. Okay. But let's say if you want to change it according to your own requirements, you have to override the default values. Those are not very significant for you. Like it might work in your non-prod environment, but you want more customized values inside your prod environment, then you can use --set. Now, what this --set is going to do is it's going to set the values according to your own requirements. Right. So if we take a look at the values.yaml file, you will see here is a replica count equal to 1. If you see the configuration of above, you will find that we have used replica count here, right? So this is the replica count. It will get replaced. This complete will get replaced, and in place of replicas, you will find the value as 1 here, right? But I have written it dynamically. That's why I have specified like this. And similarly, if you see, it says image repository is Nginx, tag is stable, right? So you will find here this complete gets replaced, like it will say Nginx : stable, like this, right? So it will come like this overall value, right? So that is the advantage, that we are making it more dynamic in nature. That's why I've specified repository and tag here. And similarly, we have container port is set to 80. So the values that you are seeing here, it will automatically replace and will replace it and set the value to 80 like this, right? So you are seeing that at the time of runtime, this complete template, deployment template is getting generated at the runtime, depending upon the values which are there inside the values.yaml file. And I also have I have the flexibility of setting these values using the --set flag as well. So again, this is the major advantage of using the values.yaml file and making our more application more dynamic, and writing less number of YAML files, right? Now, lastly, whenever you are going to develop the charts and you're going to create these directories and make it available, so once you have developed the templates, manifest, and value, you need to create a chart. Now, before you install that, you need to create a chart. So how can you create a chart? You can simply say Helm package, mychart, whatever be the name that you have provided. Now, as soon as you run the Helm package command, what it's going to do, it's going to generate a .tgz file. So basically what would happen is, like, you can have multiple files, folders, right? So if I ask you to generate a package, obviously package is like a single file. So in order to generate that single file, it basically generates .tgz file, which can be shared between your teams. You can also upload it on a repository like Helm Chart Museum, or you can use some Artifactory as well. Now, Helm Chart Museum, Artifactory, that we are going to discuss ahead in more detail, then it will eventually become even more clear to you, right? So that is what we are going to see, but you can think like that. Artifacts are the binaries which are getting generated, which you can use over a period of time. And those artifactories are basically used to share those artifacts amongst your teams. So similar way, you can generate the artifacts of Helm by writing these charts and generating the package out of him. And then you can store those packages inside these repositories. The most prominent artifactory that you will find out there is JFrog artifactory. So Helm does supports the JFrog artifactory as well, right? So once you develop the package, you create a package out of it using Helm package command, and then push them inside these artifactories, and which will be shared across your multiple team members, right? And so these are the basic commands and the structure that you need to know about the Helm. And however, this is just the starting point, right? Helm has a very great flexibility. It comes with a lot of power and managing on how you can manage your overall application. So it also allows you to deal with the dependencies. So let's say my application is further dependent upon another requirement, right? So I can specify another thing as a dependency. So let's suppose I have an application which is depending upon my Redis in-memory cache or some database. So I can put those as a dependencies, and then Helm will make sure that those dependencies are met before creating my own application. And similarly, I can put the conditional statements within my Helm as well. So we are going to take a look at them in more detail after a while. Okay, so that's all for this topic, and we are going to cover more in our next video. So that's all. If you are having any doubt regarding this, you can leave a comment. I will try to get back to you. If you have not subscribed to our channel, do subscribe to our channel for such videos. Okay, and we are going to continue on Helm in our next video. Thank you everyone for watching this video, and do subscribe to our channel. Thank you.